Right now, parked in your driveway or charging in your garage, your electric car is losing range it should never have lost. Not because of the battery, not because of the weather, because of something so simple, so cheap, and so deliberately overlooked by the companies that sold you that vehicle that once you understand it, you will never look at your EV the same way again. The dealerships charge anywhere from $200 to $600 for what they call a range optimization service. The manufacturer's app nudges you toward $300 software upgrades, and yet the entire problem, the one quietly robbing you of 40 to 60 miles of real-world range, can be resolved tonight for less than $1. The electric vehicle industry has built an empire on complexity. Every quarter, the major manufacturers, the household names you know, the ones with billion-dollar lobbying arms and partnerships with the largest energy companies on the planet, release incremental software updates that promise more range, more efficiency, more performance. And every quarter, millions of EV owners dutifully pay for those updates, schedule those service appointments, and drive away getting essentially the same range they got the month before. What they are not told is that the single biggest drain on real-world EV range has nothing to do with software. It has nothing to do with your battery cells degrading. It has everything to do with tire pressure, specifically a systematic underinflation standard baked into the manufacturing process that keeps you stopping at charging stations more often than you should. Owners across North America and Europe are collectively losing billions of miles of range every single year. They are being robbed, quietly, efficiently, and with the full knowledge of the people who built their cars. But that changes today. By the time this is over, you will know exactly what the correct tire pressure is for your specific EV, why it is almost certainly not what your door jam sticker says, how a single 30-second adjustment can recover between 40 and 55 miles of range overnight, and the precise method to do it properly so the gains are permanent and measurable. And there is one more thing, a secondary effect of this fix that almost nobody in the EV community is talking about, something that goes far beyond range. Stay with me, because the next part changes everything. The story of tire pressure and electric vehicles does not begin in a garage. It begins in the early 2010s, when the first mass-market EVs were entering production and the engineers designing them faced a problem. Tire pressure recommendations for internal combustion vehicles had been calibrated over decades to balance ride comfort, noise, handling, and fuel efficiency. The auto industry had found a sweet spot, a range of pressures that felt good to consumers and performed acceptably well. When electric vehicles arrived, those same comfort-first standards were carried over almost unchanged, despite the fact that EVs are fundamentally different machines. They are heavier, often by 20 to 30%, due to battery pack weight. They have instant torque delivery that stresses tires differently. And critically, they have no engine to generate waste heat, which means rolling resistance, the friction between tire and road, has a dramatically outsized effect on their efficiency compared to any gasoline vehicle. Research published through the Society of Automotive Engineers and referenced in subsequent Department of Energy efficiency studies showed that rolling resistance accounts for up to 25% of energy consumption in an electric vehicle under normal driving conditions. In a gasoline car, that number sits closer to 15% because engine losses dwarf it. In an EV, rolling resistance is one of the biggest enemies of range that exists, and the single most controllable variable in rolling resistance is tire pressure. Industry engineers knew this. Fleet operators figured it out by 2014. Independent EV efficiency researchers had documented it comprehensively by 2016. And yet, the consumer-facing tire pressure recommendations on mass-market EVs remained, and in most cases still remain, calibrated to the comfort standard. The reason is straightforward. Softer tires feel better at the dealership test drive. They absorb road imperfections. They make the car feel premium. And premium feel sells cars. What it does not do is maximize the asset you just paid $40,000 to $80,000 for. What I am about to show you is the part the industry spent a decade making sure you would never find out on your own. Because once you know the real numbers, you will never need to pay for a range service again. The solution is tire pressure optimization. Specifically, running your EV tires at what researchers and long-distance EV fleet operators call the efficiency ceiling, which sits between 44 and 50 psi for most modern electric vehicles, depending on the model and load. Here is why this works, and it is pure physics. Rolling resistance is the energy your battery expends simply to keep the tire rotating against the road surface. A softer tire deforms more at the contact patch, the small area where rubber meets asphalt. That deformation requires energy to constantly reshape the tire as it rolls. A firmer tire deforms less. The contact patch is smaller and more rigid. Less deformation means less energy wasted, which means more energy available to move the car forward. It is the same reason professional cyclists run their road bike tires at 100 psi and not 60. Less squish, more distance per unit of energy. The relationship is not linear. There is a ceiling beyond which you gain no further efficiency and begin trading off handling safety. But for the vast majority of EVs, that ceiling is significantly above where the manufacturer's sticker says to stop. Most people stop here, at the concept, and never do the measurement. Do not make that mistake. Step 1, do not use your door jamb sticker as your target. That sticker was set for comfort and load carrying compliance, not for range efficiency. Instead, look up the maximum sidewall pressure printed on your tire itself. It is embossed on the outer face of the tire in small print near the rim. This is the structural limit, the absolute ceiling. Your target pressure will be 80 to 85% of that number. For most EV tires with a max sidewall rating of 51 psi, that puts your efficiency target at 44 to 47 psi. For tires rated to 58 psi, your target sits at 48 to 50 psi. Step 2. Buy a digital tire pressure gauge, not the analog pencil-style gauge from a gas station. A digital gauge with a backlit display costs between 89 cents and $4 on Amazon or at any auto parts store. The analog gauges read inconsistently. For this to work, you need accuracy to within 0.5 psi. Step 3. Check pressure when the tires are cold, meaning the car has been stationary for at least 3 hours or has driven less than 1 mile at low speed. Driving heats the air inside the tire and artificially raises the reading. Cold pressure is your true baseline. Step 4. Inflate all 4 tires to your calculated efficiency target. Use the air compressor at any gas station. This costs nothing, or at most 75 cents for the machine. Add pressure slowly. Check with the digital gauge every few seconds until you hit your target. Do not exceed the sidewall maximum under any circumstances. Step 5. And this is the warning most guides skip. Check the pressure again the following morning. Temperature drop overnight causes pressure to fall at a rate of approximately 1 psi per 10 degrees Fahrenheit of temperature decrease. If you live in a cold climate and inflate it in the afternoon, your morning pressure will be lower than your target. Adjust accordingly. One mistake to absolutely avoid: inflating to max sidewall pressure and leaving it there. The maximum sidewall rating is a structural safety limit, not a performance recommendation. At maximum pressure, the tire's contact patch shrinks to the point where wet weather grip degrades meaningfully. Your target is 80 to 85% of max, not 100%. People who have taken the time to reach this point in this story are the ones who actually fix the problem, if you want to stay in that group. People who understand the real mechanics of how their vehicles work and stop paying for things they can solve themselves, then you know what to do. Before wrapping up, there is one more thing about this solution that almost nobody in the EV ownership community is talking about. Beyond range, optimizing tire pressure at the efficiency ceiling extends your tire lifespan by measurably reducing uneven wear at the center of the tread, which is the exact wear pattern that underinflated EV tires develop due to the additional weight of the battery pack pressing down on a soft contact patch. Fleet data from commercial EV operators running at optimized pressures shows an average tire lifespan increase of 12 to 18% on tires that cost $180 to $280 each. On a vehicle with 4 of them, that is a secondary saving of $150 to $400 per replacement cycle. The range fix pays for itself in minutes. The tire longevity benefit pays for itself over years. Now, consider the contrast. Before this fix, the average EV owner driving a mid-range vehicle with tires inflated to the manufacturer's comfort standard of 36 psi is operating with rolling resistance losses in the range of 18 to 22% of total energy consumption per mile. Real-world range on a 300-mile rated battery, approximately 230 to 250 miles under normal mixed driving conditions. After inflating to 46 psi on the same vehicle with the same battery and the same conditions, rolling resistance losses drop to 12 to 15%. Real-world range on that same 300-mile rated battery, 270 to 295 miles. That is the 40 to 55-mile difference you have been paying a charging network to cover. The cost of the fix, $2 maximum, including the digital gauge. The cost of continuing to ignore it, 1 additional charging stop every 2 to 3 days for the life of the vehicle. At the national average of 15 cents per kilowatt hour at public fast chargers, and remember, public charging is 4 to 6 times more expensive than home charging, that unoptimized tire pressure is costing the average EV owner between $180 and $400 per year in unnecessary public charging fees alone, not to mention the time. 20 minutes at a fast charger, 2 to 3 times a week, is over 40 hours per year spent waiting for energy you never needed to run out of. Here's what the tire pressure fix will not solve. It will not reverse battery degradation. It will not compensate for a battery management system that is slowly, quietly miscalibrating the state of charge readings your dashboard shows you. A problem that is entirely separate from rolling resistance, entirely invisible to most owners, and responsible for a different class of range loss that compounds over time. That problem has its own solution, and it is equally cheap, equally suppressed, and equally unknown to the average EV owner paying for software updates that do not address it. The fix for tire pressure is permanent and free. What comes next in that story, what is happening inside your battery's management system right now without your knowledge, is something far more consequential, and the industry's incentive to keep you from understanding it is far larger. What exactly does a battery management system hide from you? And why would a manufacturer have any reason to want your range readings to drift lower over time?